Hello and welcome everyone in the third tutorial of CPU scheduling algorithm. In this tutorial, we'll learn about priority scheduling algorithms for preemptive and non-preemptive situation. So, if anyone of you have missed the first two scheduling algorithm, FCFS and shortage of first for non-preemptive and preemptive, please check out the description and find the video and you will find it clearly. Okay, so we'll turn our attention to priority scheduling algorithm for non-preemptive process. In priority scheduling algorithm, we'll first consider the priorities of each processor that exist in the system. Okay, so first of all, at arrival time 0, we have only one process P1 in the system. Since there is no other processes in the system except P1, so we don't consider priority now at this time. So we'll consider process P1 from time interval 0 to whatever burst time it have. Because since it is non-preemptive, we'll don't consider the preemption of the resources that have already taken by process P1. So we'll consider that from time interval 0 to 8, process P1 will be served. So until after time interval 8, all the processes have come into the system. Since arrival time is maximum 3, so all the processes exist in the system. Now we'll consider the priorities of the existing processes and we'll see process P2 have the priority 1. I have forgotten to mention that for low priority, since process priority 1, for low number we will consider high priority. 1 is high priority and the increasing number will say that the priority will gradually decrease. So process for priority 4, its priority is much more less than the others. So 1 has the highest priority. So since P2 has the highest priority, we will assign P2 after P1. We will serve P2 after P1. So P2 will be served from time interval 8 to 14 because its burst time is 6. So after process P2 have been served, we see that process P4 have the lowest priority. Oh, I made a mistake. You see that process P3 and P4 have the equal priority. So in priority scheduling algorithm, if two processes have the equal priority, then they will be served in FCFS or first come first served order. Since P4 have come into the system before P3, its arrival time is 1 and P3's arrival time is 2, it will be served, P4 will be served before P3. So we'll assign P4 from time interval 14 to 23 because its burst time is 9. After process P4 has completed served, so we'll assign process P3 because its burst time is 1, so 23 to 24. So finally we'll find that process P5 has left. So process P5 have burst time 3, so we'll assign process P5 from 24 to 27. Assume that in the situation where P1 have the lowest priority but served first because it's non-preemptive. Since arrival time 0, only one process P1 is in the system. So although it has the lowest priority, it will be served first among all the processes. Okay. Now we'll see preemptive priority scheduling algorithm. In preemptive, the resources have been preempted in the meantime while a process is being served if its priority is low. So for the arrival time 0, process P1 is being served for process P1 0 to 1 time interval it is served. Okay. Now the burst time left is 7 because 8 minus 1 times served is equal to 7. Okay. After time interval 1, we see that process P4 has come into the system. Since this priority is higher than process P1, its priority is 4 and P4 has priority 2, so it will be served before P1. P1 will be preempted. So process P4 has been served from time interval 1 to 2. After time interval 2, we see that process P2 and P3 come into the system. So now we'll consider the priorities of all three processes. We see the priorities of P2 is higher than the remaining. So P2 will be served from 2 to 3. So after time interval 3, we see the last remaining processes have come into the system and its priority is 3. So now examining all the priorities of the existing processes, we see P2 have the lowest priority. So it is assigned the remaining time interval. P2 3 to 8, because remaining time interval is 5 because 1 has been served earlier. So 2 to 8, 6. Okay. After that, the priority, if we examine the priority, we see that process P4 and P3 have the equal priority. Since process P4 has come into the system before process P3, so it will be served in first come first served order. So process P4 will be served from 8 to 16 time interval, because its burst time is 9. So previously we say P4 has been served 1 time interval, so remaining is 8. So 8 to 16 is equal 8 to 16. So after process P4, process P3 will be served because its priority is 2. So P3 is served from 16 to 17. Its burst time is 1. After process P3, we see process P5 has the highest priority. Then process P5 will be served from 17 to 20. Its burst time is 3. Now we have remaining just one process P1. Process P1 has already served 1 time from time interval 0 to 1. So its remaining time is 7. So it's served from 20 to 27. So we'll see that in this way, priority scheduling algorithm from preemptive processes will work, and hope you will understand it quite well. Now we'll calculate the waiting time of priority scheduling algorithm for non-preemptive processes and for preemptive processes. Waiting time is the last time a process exists in the system minus burst time minus arrival time. So if I consider process P3 for non-preemptive priority, we see the last time process P3 have existed in the system is 24. So 24 minus its burst time, 1 minus 2 is arrival time is equal to 21. For process P4 in priority scheduling algorithm for preemptive, we see process P4 has exists in the system until time interval 16. So 16 minus its burst time 9 minus 1 its arrival time is equal to 6. In this way, waiting time can be calculated for the remaining processes. It's very easy. Turnaround time is the waiting time plus burst time. You can add waiting time and burst time to get the turnaround time. So that's all from now. We'll see another CPU scheduling algorithm, round robin scheduling algorithm, in the later tutorials. Until then, bye bye.